His camera just wasn't on.
Do you want to hear the ones that I told them?
Give us one.
I was addicted to soap once, but now I'm clean.
Oh, that's good. How long you been clean? You going to an SA meeting? Soapers Anonymous?
No.
You gotta be in with a group, or you never kick it for good.
Yeah. I met this one guy who's addicted to the hokey pokey, but he turned himself around.
That's
so
great.
it's
That's
okay.
a great, true story of redemption. Alrighty. Logarithms. Let me give a quick example. I said I would give an example of why we use these at all. Why is it useful to use them at all? Okay, well, one example it has to do with the volume of sound, which we measure in decibels. Okay. Well, it just so happens that we hear a really, really broad range of sound. Okay. We hear sound as low as 0.0002 watts per square centimeter, which is very little power. Okay, so the formula we use to convert this into decibels goes like this. 20 times the base 10 logarithm of the power of one sound over this reference sound, which is the very quietest sound you could possibly hear. The very quietest. Can you hear me right now? If you can just, yeah. Okay, the very quietest thing you can possibly hear is 0.0002 watts per square centimeter if you have non-damaged hearing and you are a child.
What's the lowest sound ever? Like, lowest sound ever?
Probably that.
Well, no, I mean, like,
hear it.
I mean, like,
record it. Yeah.
because what I heard, it was like 50 octaves below middle C is the lowest sound ever emitted from anything.
Well,
I don't know.
this is talking about volume. Yeah. So if you're talking about lower and higher sounds with regard to pitch, you're not talking about decibels. You're talking about hertz. But so that's not a logarithmic scale. Yeah.
Okay.
Okay, so with decibels. So the sound I put up here is the actual sound that's emitted, and the sound on the bottom is this reference, the lowest thing a human can possibly hear. Okay. Well, what happens if I put 0.002 watts per square centimeter up here? What am I going to yield with this formula? Let's do that. So up here I have 0.002. And then I also have it here. What is this asking? It's asking my base 10 to what power, right? My base to my logarithm, or to my exponent. My base to what logarithm will give me this over this, which is just 1, right? 1 over it's 0.002 over itself. Okay, so what over L equals, or what to the L equals, or I'm sorry, 10 to the what equals 1.
10 to the x.
Well, what number goes here? What number makes this work?
Uh,
10 to the 1 is 10. 10 to the 2 is 100. 0. Okay, Sedona's given us there.
negative.
0. Not negative 1. Negative 1, 10 to the negative 1 will give us 1/10, right? We want to know what will give us 1. Okay, well, 0 will get us there. 10 to the 0, remember anything to the 0 is 1. Okay, well that's handy for our scale here because it means this lowest sound we can hear happens to be 0 decibels. Right? 0 decibels. So one handy thing the logarithm scale does is we can set a lowest possible value and make that value equal to 0 in our new logarithmic scale. So now instead of talking about 0.0002, I can just say 0 decibels. Okay, so it's handy for numbers that are very small. There's another thing it's handy for. If it's handy for numbers that are very small, it's handy for numbers that are very large. Okay, so same formula. Except this time we're trying to figure out what is the watts per square centimeter of this sound up here. And I'll tell you that the loudest sound you have ever heard without resulting in permanent and immediate hearing damage is around 140 decibels. Okay, well, how many watts per square centimeters is that? How can I figure that out? In other words, how can I solve this for S sub 1?
Multiply by the denominator?
Well, I can't do that because this is in a logarithm, right? In my base 10 logarithm here. I can't pull it out of the
Is this
logarithm.
a lot of the stuff that you study for school? Like with the sounds and everything?
It is. It's involved, yep.
Wow.
So you're learning graduate level physics just as an example here.
Cool.
Okay, but you should be able to solve for S1 here. How do I get rid of this 20? This times 20.
Divide by
Okay,
20.
let's divide both sides by 20. 140 divided by 20 is 7.
Yes. Reading.
Okay, so I still have this over here. Now think about what a logarithm means. How do I solve here? Remember, logarithm has a base, it has a number, it has a logarithm or an exponent. And what this means is b to what number equals n. Okay, there we go. Sedona's transformed it part of the way. So just take our base and make it the base of an exponent. Take our logarithm and just make it an exponent here, right? We're just retranslating this to solve it. 10 to the 7 equals this. Now how am I going to solve this? I want S1 by itself.
So you're going to multiply by.
Okay, there we go. Yep. Well, now we can, right? Because now it's not in a logarithm. I retranslated it. Now it's not in a logarithm, so I can do that. Yep. So now I'm going to multiply by 0.0002 watts per square centimeter. And now I can just plug this in, right? I just plug this into my calculator. 0.00002 watts per square centimeter times 10 to the 7th. So if I plug that in, I get 2,000 watts per centimeter squared equals 140 decibels. Okay, so that's why we use decibels, right? It's very useful. So now instead of talking about a scale from 0.0002 to 2,000, which is, so let's see, this one is 10 million times larger than this one, right? This one is 10 million times larger than this one. So instead of talking about a scale that differs from 0 to, or I'm sorry, basically from 0 to 10 million, right? Instead, I'm talking about a scale that differs from 0 to 140. So it makes it much more manageable and much more intuitive. And that's why logarithms are useful. Now, today and tomorrow are now open for questions from lessons 25 and 26. So this is time for you to work on those lessons so you don't have that homework over Thanksgiving or to ask questions on it.
I'm sure we'll have some.
Good. Yes. Yeah, I was just looking up those questions. So I'll start with the first one on your list, Sedona. Number 2. On the first lesson, right? On 25. All right, Emerson can dig 2 holes in 3 hours, and Jonna can dig 3 holes in 2 hours. 6 holes need to be dug. If Emerson digs for 1 hour and then is joined by Jonna, how long will they work together to finish the 6 holes? Okay. What rate do you think we'll be looking for? Well, yeah, they're going to have different rates, right? They're digging at different rates. How are we going to quantify those rates? Holes per hour. I absolutely agree. Holes per hour. Okay, so how many holes per hour does Emerson dig? 2/3, right? So it said Emerson digs 2 holes in 3 hours, so 2 over 3 is his rate in holes per hour. Holes per hour. Again, we can make sure these cancel to check whether we're doing it right. Okay, and for him, I'm going to be multiplying by a certain number of hours, right? So how many hours is he going to be digging? 1 hour, and then first 1 hour, and then X, then some unknown number of hours, right? Okay, so that's Emerson. What about for Jonna? We need her rate, right? And then we need her hours.
So it should be 3 over 2. 3 holes per 2 hours.
There we go.
And her
Yep, 3 over
hours
2.
X, right? Because we don't know anything about
Absolutely. Okay, and how many holes do we want them to dig? 6. All right, so that's how we set that up. We identify the rate, we find the rate, and then we draw out algebraic equations for the hours. Okay, I knew that this was my rate, holes per hour, and not hours per hole, or you knew that right away, because you know you want hours to cancel out, because ultimately you want this to equal 6 holes. So you want hours to cancel out. 6 hours. If they do, then you've done your rate the correct way. Is that clear?
Yes.
Okay. Next up, I have number 17. Okay, here we're solving for, it looks like excellent. X squared plus y squared equals 9, and 2x squared minus y squared equals 6. All right, we have 2 variables, 2 equations, which means if there is a solution, we should be able to find it given these 2 equations. Any ideas?
Could you use elimination for the y squared?
That looks promising. Yeah. Okay, or you could make a substitution equation. You could do that too. Okay, so if we're doing a substitution, I could say subtract 6 from this, add y squared to this, and then my y squared would equal 2x squared, 2x squared minus 6, and I substitute that in. Or I could use elimination and just add them together. Okay, either way, they look about equally simple. So since they're already set up like this, I'll just add them, since that will eliminate my y squared right away, and will give me 3x squared, right? 3x squared, my y squareds are eliminated, 15. What now?
Divided by 3. Both sides.
Okay. What's x then?
The square root of 5.
Is it?
Mm-hmm. I don't know.
Just the square root of 5? Plus or minus, there we go. Yep. Don't forget plus or minus. Okay, plus or minus the square root of 5. Okay, so we have two different solutions for x. In order to get y now, I have to plug these into another equation, right? Where would be a handy place to plug them in? Okay, first equation, I agree. I think that one will be easiest. All right, so let's plug that in. Square root of 5. Let's just say right away, plus or minus square root of 5 squared plus y squared equals 9. What now?
Square root of 5. Squared is going to be 5.
Okay, whether I'm using either one, right? Whether I'm using positive or negative square root of 5, it's just going to be 5.
Correct. So then isolate y squared. Square root.
Okay.
Mm-hmm. Y equals 2.
It equals what?
2.
It does?
Plus or
Yes.
minus 2?
It equals 2.
Okay.
Yeah,
Making
plus minus 2.
questions.
Is it really? Are you positive?
What's negative 2 squared?
It's 2.
4.
Oh, yeah.
4.
4.
Yeah.
Not
You have yourself.
It's okay.
Okay, so my x could be plus or minus square root of 5. My y is plus or minus 2. So how many xy solutions am I going to have? How many pairs? How many possible xy pairs am I going to have?
2.
4?
4. Yep. Yep. 2 choices for the first, 2 for the second. So that means whatever shapes these 2 equations are describing, we know that they intersect in 4 different places. Yep. But for now, you can stop at the x equals plus or minus square root of 5, y equals plus or minus 2. Yep, but make sure you go through solving that on your own as well. Is that clear?
Yeah, clear as mud.
Clear as mud.
There's my coffee.
Next question on the list is number 27. Okay. I was Oh, okay. Yep. So 27 should be pretty straightforward. Just make sure when you're reading measure of arc DCE is 290, that you're going in this order from D to C to E, right? Oh, okay. Yeah, so that one should be fairly easy to figure out. If anyone has trouble on 27 beyond that, you can look in lesson. There's a lesson that I've referenced a good bit. 13. If anyone has trouble on 27 or things like that, it's all in lesson 13. Laid out pretty clear. Anything about arcs and central angles and all that. And okay, last question on the list so far is number 29. All right, let A, B, and C be real numbers. So A, B, C, real numbers, where A is greater than 0, B is greater than 0, C is less than 0, and AC squared greater than BC squared. And I want to compare A and B. What do you think? Yeah. Yep. So I would probably approach this by plugging in a test case, being careful to meet all of my criteria where C is less than 0, A and B are greater than 0. I would plug in a test case and then think about, are there exceptions to that, or does that hold universally? Positives and negatives are off. But let's at least set that one up on 21. 3 minus 2 square root of 12 over 4 plus 3 square root of 3. So what is the conjugate of the denominator?
It's 4 minus 3 radical 3.
There we go. Okay, so I'm just multiplying by a convenient form of 1 here, as we have often done. And then I'm going to multiply them using first outside, inside, last. That's what I do. So first, outside, negative 12, inside is going to be positive 12, so that's going to cancel out. So my outside and inside cancel out. And then my last, 9 times square root of 3, which is 327. Does that make sense? So when you set up the conjugate, your outside and inside cancel out. So really you're just squaring the first two numbers and the last two numbers and adding that together. But it's not going to cancel out up here because this is not the conjugate of the numerator.
I know what I did wrong. Never mind.
Okay. Alrighty, day 1 of 2 for this week is fait accompli. It's a done deal. I'll see you tomorrow.
Oh, it's a video.
So,
Thank you, Mr. Neely.
Thank you.
Guten Tag.
thank you. I'll see you tomorrow. Thank you, Miss.
See you later.
Excellent.